Hey, how you doing? I'm Elton, and this is the second part of the Docker MTA series, Modernizing .NET Apps for IT Pros. In part 1, I covered what MTA looks like for .NET applications. You've seen the benefits in portability, security, and efficiency you get when you move your apps to Docker, and in this video, I'm going to show you how to do it. I'm going to take a .NET 3.5 application currently running on Windows Server 2003, move it to Docker using a PowerShell tool, and then run it in a container. Here's the app I want to modernize. It's called signup.web, and it's a simple ASP.NET web form site which uses a SQL Server database. It's a newsletter sign-up application which stores users' contact details, and these drop-down values come from reference data in the database. Right now the app runs on Windows Server 2003. My test environment uses a single VM for the website and the database. The easiest way to move a .NET application into Docker is with Image to Docker, a free open source tool. It's a PowerShell module hosted on the gallery, so back on my Windows 10 client machine, I'll install the module and then import it so it's ready to use. The convert to Docker file commandlet extracts applications into Docker files. It can Dockerize apps on the local machine, or on a remote machine, or from a virtual machine disk. I'll use the VHD for my test server, and I'll write the output to my C drive. Image to Docker can work with different application types, which it calls artifacts. This is a web application, so I want to look at IIS on the VM. If I run the command now, Image to Docker will pull all of the web apps out of the VM into one Docker image, but it's better to run a single application in each Docker container, so I'll pass a parameter to extract just one website, signup.web. Now, Image to Docker mounts the VHD and extracts the ASP.NET application. The output from Image to Docker is a Docker file, which is how you package applications in Docker, and all the content for the app copied out from the VHD. The Docker file is straightforward, less than a dozen instructions, and this is all you need to move a traditional app into Docker. It starts from Microsoft's ASP.NET 3.5 image. That image uses Windows Server Core, and it comes with IIS, .NET 3.5, and ASP.NET already configured. Image to Docker found that the source website on the VM used ASP.NET 3.5, and it's chosen this as the most appropriate Docker image as the base. The shell instruction switches to PowerShell for running commands in the rest of the Docker file. Even if the Docker file syntax is new to you, the majority of the work is done in PowerShell, and it's pretty clear what's happening. This line sets a registry entry to turn off the DNS cache in Windows. You need to do that to make sure the container always checks the DNS server in Docker when it's looking for services. That way, it always gets the current address for other containers. Next, remove the default website from IIS and create a new directory and website for the application. The website name, the path for the content, and the port are all brought across from the original VM. Docker containers are locked down unless you explicitly allow network traffic into them, and that's what the expose instruction does. It's like a firewall opening traffic to the website port. Now, copy the website content from the local machine where Image to Docker extracted it from the VM. The last section sets the ownership of the web directory to the IIS user group so that the app can write files to that directory. I don't need to change anything in this Docker file that the tool generated. This is all ready to package in Docker. Packaging the app in Docker means building a Docker image. I'll change to the directory where my Docker file and the website content are and run docker image build. The tag is the identifier for the image, which I'm calling newsletter signup app v1. Docker executes each of the commands in the Docker file, and the final output is an image. The image is actually built up of many layers, which Docker will cache to speed up the build and distribution. Each instruction in the Docker file creates an image layer, and these are the layer IDs. And if the instructions don't change between builds, Docker reuses cached layers. The image is the portable unit, so I can share this on a public or private registry, and anyone with access can download the image and run the application. To run the app in a container, I use Docker container run. Detach means the container will run in the background, and publish publishes the port, so Docker routes traffic into the container. The output is the container ID, and I can check the container is running with Docker container list to list all running containers. Each container has a virtual IP address, which I can use to access it from the host. Docker container inspect gives me all the information about a container, including that IP address. I'll browse to port 8090 on the container and I'll see my application. So this is my .NET 3.5 app extracted from a Windows Server 2003 machine now running in Docker. I've actually got an error screen, so something isn't working right, but Docker isn't a black box. I can connect to the container and see what's happening. In the website content there's a config file which has a logging section. Any errors should get logged to the signup.log file in app data, so that's where I can look in the container. Docker container exec runs a command inside a container, and with the interactive and terminal flags, I can connect to a PowerShell session. This is PowerShell running inside the container now, and I can read the log file with get content. The error is that the app has failed to connect to SQL Server. Back in the web config file, here's the connection string for the database, and it's expecting to find SQL Server on the local machine. The container doesn't have SQL Server, so that's why the app is failing. I'm going to run the database in another Docker container, so I'll change the connection string. The data source will just be the container name. At the moment, the config file is baked into the Docker image, so I need to rebuild the image to package the new configuration. There are better ways of configuring apps in Docker, but this is an easy approach when you're getting started. I'll make a change to the Docker file too, so that I can read the logs without having to connect to the container. These instructions change how Docker starts a container from the image. The entry point command is going to run PowerShell, start the IIS Windows service, browse to the local site, which starts a worker process running, and then watch the application log file. That means log entries get relayed back to Docker, and they can be read from the Docker command line and from any of the plugins for logging that the Docker platform supports. I'll build a new version of the image, tagged v2, and you'll see a lot of the image layers come from the cache because the Docker file instructions haven't changed since the last build. Only the last few instructions are executed, and the output is a new image with my new database configuration and logging setup. Running SQL Server in a container is perfect for test environments. I already have an image with my database schema deployed, which runs on top of the SQL Server Express image from Microsoft. I'll run a detached container from that database image and make sure the container name matches the server name from the application's connection string. Now I'll run the web application in another container and grab the container IP address. When I browse to the new container, I see the home page as expected, and I can go on to enter some details here. When I submit the form, the data gets saved to the database in my SQL Server container. That log relay that I put into the Docker file means I can run Docker container logs and see the output from the application log without having to connect to the container. Here there are log entries showing the data I've just saved in the app. My application is working just fine in Docker now, with no code changes and just one config change to update the database connection string. My Windows 10 machine doesn't have IIS or .NET 3.5 or SQL Server installed. All you need to run this application is Docker. Everything else is packaged in the Docker images. I started this video with an old .NET 3.5 app running on Windows Server 2003. 10 minutes later, I have the same application running in a Docker container based on Windows Server 2016. Docker is a modern application platform. that makes it easy to move your app to a different host or a different data center or even to the cloud. It also makes it easy to manage your app and deploy application updates and Windows updates, which is what I'll be showing you next. That's coming up in part 3 of Modernizing .NET Apps for IT Pros.